Hello, Honors Chemistry, and welcome to your Chapter 2 review. So, what we're going to do is we're just going to point out some things we need to know, and then we'll do a few practice problems together, just so you can sort of see the problems being worked one more time, listen to the explanations one more time, and sometimes people find that helpful. Alright, so things you must have memorized first of all for this chapter. Obviously the element names and symbols. There will be a section on your test that is just element names and symbols. It'll probably be, I don't know, 40% of the test grade will just come from element names and symbols. Then obviously you have to have the prefix table memorized, right? And these 4 English to metric conversions. And again, if you want to memorize that whole table, knock yourself out. These, any conversion that I give you, you will be able to do them with these 4. Obviously some of those other ones will get you there much faster, but however much you want to memorize. Okay. All right. All of this is from your book and your notes, so we're not doing those. Let's do a little bit of sig fig practice. Okay. So here, again, a measurement can't start until we get to a number. So here, this would be 3 sig figs, right? Scientific notation is always easy, whatever's out front. Here, this one, since these zeros are not after digits and decimals, they're ambiguous, so we would just go with the 1. Same thing here. Okay, I didn't give a lot of very good examples for that. So for example, 203.00, right? These are after digits and after a decimal, right? So in this case, all 5 are significant, okay? Obviously, if it's embedded between, it must be significant. All right, and again, some scientific notation practice, right? So make sure you understand all of that. All right, let's go ahead and do some actual practice problems. I think there are a few on this page that I picked out. All right, so let's go ahead and do 500 grams to picograms. So first step, let's start with our given, right? So 500 grams. Make space for our conversion factor. Let's figure out what our conversion factor is, right? Grams to picograms. So we should always think to ourselves, there's going to be one big thing equal to lots of little things. So we know gram is a base unit, so its exponent is 0. Pico is, right, 10 to the 12 smaller than the base unit. So that means there's going to be 10 to the 12 of my small things for every one of my big things. And then we're going to fill in our conversion factor appropriately. And then we're going to double check our units, and then we're going to do our work, which is 500 times 10 to the 12 picograms. And then if you want full credit, you're going to have to figure out how to fix this and put it in proper scientific notation. So this says 10 to the 12th, right? So what this is saying is we would have to move 12 spaces in which direction? Right, this way. So if I want to then come this way, how many spaces do I have to go to get to that same place now? Right, now I have to go 13, and now I have to go 14. So 5.00 times 10 to the 14th picograms. And it makes sense because picos are smaller, so I should have relatively a bigger number. Yeah? Okay, next up. We're going to do 595 micrograms to, what is this? Megagrams, right? So again, don't get confused. There are 3 different M types of M's, okay? So we're going to start with our given, 595 micrograms. And then we've got to come up with our relationship. So micrograms, megagrams. So micro is, right, 10 to the 6th smaller, right? So if here's 10 to the 0, micro is down here. Mega is, right, 10 to the 6th up, which means how many total decimal places are between them? Right, 10 to the 12th. So one big thing, which is the 1, right, to 10 to the 12th small ones. So we're going to have 10 to the 12th micrograms for every 1 megagram. So then we're going to get 595 times 10 to the negative 12, because we're bringing it up, which means we subtract it, right? And then now we just have to figure out how to adjust that decimal again. So let's cancel these, right? Megagrams is left. So here, but negative 12 says we're moving in this direction, right? So if I have to come here, how many places do I have to go now to get to the same destination? Right, now I have to move 11 and then 10. So this is going to give us 5.95 times 10 to the negative 10 megagrams, right? And again, it makes sense. I've gone to a larger unit of measure, right? And there are relatively a smaller number of them. Okay, next page. Okay, so here we have this one. What makes this one different than the last few? Right, we're looking at units that are cubed. So that means we're going to start it the same way. We're always going to start with our given, which is 3.25 times 10 to the 4th meters cubed. The only thing that makes this more thoughtful, right, we're going to come up with our one-dimensional relationship between meters and kilometers. Which is the bigger one? Right. The relationship is 10 to the 3, and then we'll apply whatever it is to the entire conversion factor, which means 10 to the 9th meters cubed is equal to 1 kilometer cubed. So down here it'll say 10 to the 9th meters cubed for every 1 kilometer cubed. Those cancel. All right. And so again, this is on the bottom, so we're going to end up with 3.25. Subtract kilometers cubed. All right, I think there was one more down here. All right, so we have 0.5 milliliters per hour, and now we have to do a two-part conversion. So, and note that if this reminds you of a conversion factor, it's because it is, right? We could also use this as a conversion factor if that's what the question we're asking us to do, right? But in this case, it's asking us to take basically convert our conversion factor into a different kind of unit, right? So we need gallons per day. So first of all, let's see what needs to get converted, right? This is my unit of volume. Gallons is a unit of volume, so I need to get milliliters and gallons, right? So I know, what do I know? I know 1 gallon is equal to 3.785 liters. And I know that 10 to the 3rd mils is equal to 1 liter. What else do I know? Right, I know that there are 24 hours in one day. So putting that all together, let's go and use this one first. And then hours cancel, so that's good. Mils, there are 10 to the 3rd mils for every 1 liter. And there are 3.785 liters for every 1 gallon. Mils cancel, liters cancel. Remaining units are gallon per day. So then here, in terms of solving, what we're going to do is we're going to multiply across the top. So our math is actually 0.5 times 24 on top of 10 to the 3rd times 3.785, and then our unit is going to be gallons per day, right? So we do this, we multiply, and then we divide, and let's see what we get, right? If we take 0.5 times 24, we get 12 divided by 3.785 times 1,000, and we're going to get 0.00317. And then what happens? Right, we're going to round it to 1 sig fig, so we'll just say 3 times 10 to the negative 3 gallons per day. All right, I think there's not this page. All right. A serving of a cheeseburger has this mass, by the way, which you'll need later. But anyway, if we look at this, right, like so many things are conversion factors. So here we have lots of conversion factors, right? We know that 1 burger is equal to 303 grams, right? We know that 1 burger is equal to 840 calories, if that's what we were interested in, right? We know that 55 grams of fat is equal to 303 grams of burger, if we wanted to, right? We could even look at our percent values, right? So for example, 84% fat of the daily value, right? So here this is just an estimated amount that the average person might need in a day. So 84% fat is equal to 1 burger, right? So these are all just relationships we can come up with based on what's here, right? Wherein all we're doing is writing equalities, right? Two things that happen to be equal to each other based on the information that we know. So this one says how many grams of protein are in 3 cheeseburgers. So 3 cheeseburgers is my given. Protein is right here. And going back up again, that was this per serving, which was 1 cheeseburger. So I'm going to take my 3 burgers and I'm going to convert, right? I know that for every 1 burger, there are 47 grams of protein. And then I would do 3 times 47, and that's going to give us our 141 grams of protein. Here sig figs get a little bit funny. So technically, if we're counting in whole numbers, this is a defined 3 with an infinite number of zeros, so we could have this to an infinite number. So actually, whatever you round this, the rounding here is irrelevant. We're just practicing the art of converting and seeing and finding relationships. Okay, next up, last couple problems to practice from. So here it says, so density practice problems. And again, if you're prone to confusion, please take a moment and just rewrite your densities, right? Anything with 2 units is a conversion factor. Here, if I know I'm talking about nitrogen, and I'm given a, what is this? Volume, and I want to talk about mass. Let's go ahead and find our density of nitrogen, right? 1.25. I don't know why it looks like that. Grams is equal to 1 liter. Write it out, right? So that you can see the 2 parts. So let's take our 2.0 kiloliters, because we're always going to start from our given. What comes next? Right, this doesn't actually match yet, right? Let's say you tried to put this down here, and you're like, oh, 1.25 grams. And then you go cancel, and you're like, something is amiss. So then we could just add another step, right? We could erase this one if we prefer. Or thinking back to our conversions where we're talking about converting a numerator and denominator, right? All we have to do is just fix it, right? Liters doesn't cancel here, but what can I do? Right, 10 to the 3rd liters, 1 kiloliter. Kiloliters cancel, liters cancel. I've converted to mass, right? And then so we would just have to do the math. We would multiply across our top, which is 2 times 1.25 times 1,000. And then we would get our final answer, grams. And then sig figs, we're done. Okay, next up, what is the volume of this much mass of helium? So that should make us think volume, mass, ding, 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 density. So 0.1785 grams are equal to 1 liter. So then let's set up our work, right? Let's start from our given. -3 kilograms. And then we'd look over here like, again. So do you see how these need to become second nature because they're just sort of worked into every other problem? That's what happens all year long. So I can't emphasize enough that everything we're doing in Chapter 2, essential foundations here. Okay, anyway, 0.1785 grams per 1 liter, right? Grams, kilograms. And then we'd have to set it up, right? So here we have 10 times -3 and a 10 times +3, right? Those basically sum up to 0. So really our math is only 5 divided by 0.1785. And we're going to get 28.011, etc. liters. And last step, right, 3 sig figs. Okay, so do be mindful, right? Some of these get a little bit more thoughtful, like for example here, mass of gold. Nope, that was not, well, medium thoughtful. Where we have here, millimeters cubed. What's that a measure of? Right, volume. But we're going to have to remember to, right, apply the concept of cubes, right, and cube my entire conversion factor, right? Same thing here. That's a volume. So you need to convert and cube all your conversion factors, but only the volume ones, right? You're not going to cube the density conversion factor, for example, right? That doesn't make sense. Okay, so that's just a few practice problems so you can see them worked again and hear the explanation as you're working. Other than that, I hope you're working productively on the review packet. Have a wonderful day, be good, and thanks for listening. See you soon. Bye.